Welcome to MathSci Catch-up Lessons, where we tackle past matric question papers and also we cover grade 11's question papers in maths and science. In this segment, we are going to cover the last part that deals with your question 1 and question 2 of your question papers. And this last part, if we look at the slide, we are going to deal with the nature of roots, and we are going to deal with simultaneous equations, and we are going to deal with quadratic inequalities. Now let's start with the nature of roots. Remember, we spoke about different methods in trying to solve quadratic equations, right? Factorizing, completing the square, and if you can't find factors of x, we also used a quadratic equation in a form of x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Now, in this equation, we take out this part. And this part is actually the part that helps us determine the nature of roots, and we call this part the discriminant, right? The discriminant. Now, finding the nature of root is basically trying to find the type of numbers that your x should be, meaning the type of roots your x should be. So like I said, we call this number we call it the discriminant, which is notated by delta. So we say delta equals b squared minus 4ac. Now guys, there are different methods, or there are different ways in which a question in your question paper might be asked in determining the nature of roots, and I have summarized these ways or these methods. A question paper can say determine the nature of roots, or it can say show or prove the nature of roots, or find the value of a, find the value of a missing variable if the nature of roots is given in that case. Now going back to our nature of roots, remember, in this case, if let's say you have these conditions for your discriminant, let's say you have your discriminant less than 0, meaning then your roots will be non-real. Now what this means is, if you have your discriminant, remember this, the discriminant is under a root, right? The discriminant is under a root. Let me try to make it clear. The discriminant is under a root, right? Now, the first condition, if your discriminant is less than 0, meaning let's say you have a -1, this would be non-real. Your roots will be non-real. And let's say now you have your discriminant equals 0. Again, it should be under a root which is 0, right? They say then the roots are real, rational, and equal. Meaning, if they are real and rational, and if you type the square root of 0 in your calculator, you will obviously get 0, right? And the equal part, in this part here, whether you add or you minus, you still get the same number. Let's say now this is minus 5 plus the root of 0, or minus 5 minus 5 minus the root of 0. You will get the same thing. You will get the same thing, which is minus 5, right? Meaning your roots will be rational, real, and equal. Let me try to get some space because I'm gonna explain. I don't want to move to the next slide. All right. The second part is if your discriminant, the third part is if your discriminant is greater than 0 and a perfect square, then your roots are real, rational, and unequal. Meaning, if you have a perfect square, let's say you have a 4, which is a perfect square, it's going to be 2 plus or minus any other number. It is this part here, unequal. If you add or minus any number, your roots will be unequal. And the last part is if the discriminant is greater than 0 and not a perfect square, then your roots are real, irrational, and unequal. Again, let's say you have square root of 10. You have square root of 10, which is irrational, but then it's real, but then again it's unequal. So guys, these are the terms of your nature of roots, right? We solve the nature of roots by a discriminant. Now let's move on to the next part. The next part is simultaneous equations. Now in these cases, you get two variables that you need to solve, right? You get two variables that are unknown, obviously, and you need to solve both of them. Now we solve these cases either algebraically or we solve them using graphs. Now using graphs, you might be given a parabola and a straight line graph, right? Now you solve simultaneous equations by determining the points of intersections. Where these graphs intersect, it's how you solve simultaneous equations graphically. Where they intersect, It's how you solve simultaneous graphs graphically. Or we can use algebra to solve simultaneous equations, right? Let's move on to the last part. The last part is quadratic inequalities, which are basically quadratic expressions, but then now there are restrictions, or there are terms in which your x should be solved. There are terms in which your x should be solved, and we will discuss that in our examples. Now guys, talking about the examples, our examples will be mainly question papers. Like I said, we will try, like I said at the beginning of this broadcast, our aim is to try to make you guys understand the layout of the question papers. Now for us to do that, meaning we have to do all our examples should be based on past question papers. Now getting to past question papers, we are going to finish up question 1 and question 2 of what we've been dealing with. Now here they say you should solve for x, and you are given x minus 1 plus 3 equals x. Now when you get this sum, the first thing that you should do is try to get it in a standard quadratic form, right? Now how do we get there? All right, we are going to get rid of the square root by squaring, and we are going to transpose the 3 to the other side of our equal sign, meaning we are going to have the square root of x, minus 1 all squared equals x minus 3 all squared, and we are left with x minus 1 equals x squared minus 6x plus 9. Now let's try to get everything on one side. We are going to have x squared, and then we are going to have minus 7, and then here we are going to have 10 minus 7x. If you take the 1 to the other side, it's x squared, we take it there, it's minus 7x. We take the 1 again to the other side, which will give you plus 10 equals 0. Now let's get the factors, which is x in this case we are going to have factors of let's say minus 5 and minus 2, meaning now your x equals 5 or your x equals 2. Your x equals 5, your x equals 2. Now before we move on to the next question, what is important is always try to check your answer, because you might lose your a few marks or even 1 mark for not going back and checking your answer. Now in this case, we need to take our values for x, which is 5 and 2, right? Try to substitute them in our original equation. right? Now let's have a 5. If we have a 5 in the space of x, it's going to be 5 minus 1, which is 4, square root of 4, square root of 4, which is 2. Yeah, we're going to have a 5. 5 minus 1 is 4, square root of 4 is 2, 2 plus 3 is 5, and then again we take the 5 to the other side, so meaning we are going to have 5 and 5 on both sides, meaning this one our solution is correct. And then again we take the 2, substitute it back. A 2 here will give you 2 minus 1, which is 1, square root of 1, which is 1. And now we are going to have a 4 on this side, and then we are going to have a 5 on this side. Now meaning your x should not equals to 2. Your x should not equals to 2. This is fine, but then here remember you put a cross across your equal sign. Let's move on to the next question. The next question is 1.1.4. So this one is x squared is greater than 3 x squared is greater than 3 into x plus 6, x plus 6. Now in this case, as you can see, we have an inequality sign between our expressions, meaning we are dealing with a quadratic inequality. Having an inequality between your two expressions, we are going to solve this differently, but then we have quadratic methods in which we solve this, and you should get this into a proper quadratic form before you solve it, right? Now after getting your values, now we don't call these values now your factors, we now refer to them as your critical values. Your critical values. Now we are going to get this into your standard quadratic form, and then determine our critical values. Now let's start. Meaning we are going to have x squared greater than 3x. If we distribute this today and then we distribute that to the 6, it's 3x plus 18, and let's get everything else on one side. It's x squared minus 3x minus 18 greater than 0. Now from this point, what we need to determine is the critical values, meaning what needs or which numbers or which values apply here for our statement to be true, right? For our equation to be true. Now dealing with that, let's get our critical values. We are going to have x greater than 0, and then we are going to have minus, let's say, plus 6, no, minus 6 actually. So it's minus 6 plus 3 plus 3. Now from this point, there are different methods in determining your critical values. And we normally use the number line before you notate your answer, right? Now the method that I've found easier and much simpler is this method here. Is you take your critical values, right? And you draw your number line. I'm gonna need more space, so let me get rid of this part. I would have my number line there. Now in this case, it should be minus 3, which is this part here, and then a 6, right? Remember our critical values, write them over here. It's minus x minus 6, and then x plus 3. I'm trying to make the dots. Okay, let me just do this. Now in our number line we have a 3 and a 6. Now what I normally do is take any number which is less than 3, any number which is less than 3, and substitute it in one of our critical values. Let's say we have, let's take minus 4. Let's take minus 4, and then we substitute it here. We substitute it here, right? So it's going to be minus 4 minus 6, and we only take the sign for that. So minus 4 minus 6 will give you a negative, right? Minus 4 minus 6 will give you a negative. Minus 4 minus 6 will give you a negative, right? Again, we do the same on our next critical value. We take minus 4 plus 3, which will give you again a negative. And then we move on to our next critical value, which is 6. Or we can again take a 3 here and say we take any number greater than negative 3, right? Let's say negative 2. Negative 2, again we substitute again here in our number line. Like I said, negative 2 will give us a negative sign, right? Negative 2 here will give you a positive. And then again, let's move on to the 6. Any number greater than 6. Let's take a 7. A 7, substitute it here, will give you a positive sign. Again a 7, substitute it here, it will give you a positive sign, right? Now from here we determine the products of our signs, right? Now a negative and a negative here will give you a positive, and then a negative and a positive will give you a negative, and then a positive and a positive will give you a positive, right? Now we go back to our equation. Right? which is, let me rewrite it down, which is x squared minus 3x minus 18 greater than 0, and then our critical values were x minus 6, x plus 3 is greater than 0. Now, looking at our signs, we look at where is your x greater than 0 on your number line. As you can see, x is greater than 0 for any number. For any number which is greater than 3, and for any number which is greater than 6, right? Now, writing this as your answer, it should be in this form. It's negative 3, it's 6. Like I said, your x is greater than negative, your x is greater than 0 for any number which is greater than negative 3, and for any number which is greater than 6, right? Now we note this by saying x is an element of close bracket negative infinity to 3. I'm gonna run out of space. Let me write it here. Again, it's negative 3. It's negative 3. It is 6. Now, writing this in a notation form, we say x is an element of negative infinity and negative 3, and then we close our bracket, because any number which is false on this part, any number which falls on this part doesn't satisfy our value, right? Any number which falls here doesn't satisfy our value, right? And then remember, we are dealing with a quadratic equation which are represented by parabolas. Now, for you to know whether your parabola is going to be a negative or a positive parabola, remember, a positive parabola, you would know, would be a smiley face, and then your negative parabola will be your frowny face in a way. Now, how do you know that? You know this because if your a is positive in a standard quadratic form, if your a is positive in a standard quadratic form, if your a is positive, meaning it's greater than 0, your graph will be a smiley face. And then if your a is less than 0, you will have this sort of graph, right? And these are also your maximum and minimum values. your maximum and minimum values. Now going back here, your A here in this case, your A, which is here, is what? It is positive. It is positive, right? It is positive, meaning you will have a smiling parabola, right? Meaning you will have a smiling parabola. And then finishing up here, we will have a close bracket because everything here doesn't satisfy our values. And then we will have 6. And everything going this way, which is any number greater than 6, meaning it will be infinity, and then you close your bracket because it goes on and on and on and on and on and on. Now this is how you are going to get marks if you represent your answer in this form, here. That's where your marks lie. You show your answer on the number line, and then you write your notation, right? You show which critical values apply in this case of our inequality. Now recapping our answer, it should be in a notation form, in this form, and it translates your x is an element of any number which is less than 3 and any number which is greater than 6. Any number less than 3 and any number which is 6 and greater than 6. Let's move on to our next part, to our next question, still on grade 11, November 2017 question. Now this one says solve for x and y simultaneously right. Let me get rid of that because I'm gonna need more space, but then you have the question. If you have a question paper, you should know number 1.2. We are dealing with that. Now we have 2x to y, 2y plus x equals 1, and x squared plus y squared plus 3xy plus y equals 0. Now solving simultaneous equations, what you should do first is determine which equation or which expression is much simpler to deal with when you make one of your variables the subject of the formula, right? Now in this case, looking at this, these two equations and you try to determine which one is simpler, right? I would go for this one here. I would go for this one here and make x the subject of the formula, meaning I would have x equals minus 2y plus 1, and I would continue and call this my equation 1, and this would be my equation 2. This would be my equation 2, right? And your next step is try to substitute wherever you see your x into equation 1, right? Wherever you see your x into equation 1, right? Meaning your statement should be substitute 1 into equation 2. Substitute 1 into equation 2. I'm going to run off space because normally simultaneous equations are very, very, very long questions. So I'm going to rewrite this and say x equals minus 2y plus 1. I said this is our equation 1, and then x squared plus y squared plus 3xy plus y equals 0, and then we call this our equation 2, right? Now let's proceed in substituting. Now, like I said, wherever you see your x, you put minus 2y plus 1, right? Meaning in this case, we are going to have minus 2y plus 1 all squared plus y squared, and then this we have another x, but then I can write this as, to make things a bit easier for us, I can say 3y into minus 2y plus 1 close bracket plus y equals 0. Now let me continue by substituting. Here we are going to have minus 4y plus 4y squared 4y squared plus 1 and then have y squared, and then here we have minus 6 squared plus 3y it's 6y squared plus 3y plus y. Now let's try to cancel out. Let's see what we have in terms of like terms. We have minus 4y and we have plus 3y plus y, and then we have 4y squared, and then we have y squared, and then we have minus 6y squared, meaning here we are going to have 0, and then here we are going to have minus y squared, and don't forget our 1, meaning we are left with 1, right? Meaning from now on we can get the factors of y. 1 plus y equals 0. Let's double check. 1 times 1, it's 1. 1 times y, it's y, and then minus y times 1, it's minus y. The y's are going to cancel out, and then here we have minus y times positive y, which is negative y squared, meaning your terms should be minus y equals negative 1, or your y equals negative 1. And then let's get rid of this minus here, meaning your y will be 1. Now from this point onwards, you have determined your values for y, meaning you can take those values, substitute them back into one of the equations. Now what you should be doing is try to pick up a simpler equation, right? Pick up a simpler equation for which you're going to substitute what you have for y. Now in this case, I'm going to substitute it back to this equation here, right? Meaning I'm going to have x equals, we start with the 1, say plus, meaning your x would equal negative 1, and then if you substitute the negative 1 again here, you will get x as 3. X equals 3, because a negative and a negative is a positive. So your values are your y equals negative 1, and then your y equals 1, and then for x you have x equals negative 1, and then x equals 3. Those are your values for x. Now I think you've noticed we've covered what we've been dealing with in terms of our revision, and it basically gives you an idea of the type of questions that you are going to deal with in your exam. Now moving on to the next sum. All right, let's move on to 1.3 of the November 2017 paper, of which it says if f of x equals 0, has roots x equals minus 5 plus or minus the root of 3 minus 12k squared all over 4, and then it continues to say for which value of k will the roots be equal. Now, dealing with this from the first point, or what should come to mind is the discriminant, right? And the nature of roots. Now, your discriminant, if it's greater than 0 and it's a perfect square, we say the roots are real, the roots are rational, and they are unequal. If you have the discriminant which is greater than 0, but then they are not a perfect square, the roots are real, irrational, and equal. If you have the discriminant which is equal to 0, the roots are real and they are equal, right? Meaning you need to get your final answer needs to satisfy our statement, meaning this part here, which is your discriminant, whatever answer you get for k, whatever's under this root here, you should get a 0 for us to be able to say, you know what, this question is correct. Meaning if we have a 0, we have real equal roots, right? Now let's try to solve it. Let me clear my board. Let's try to solve it. It's x equals minus 5 plus minus the square root of 3 minus 12k squared all over 4. Now remember, we are dealing with the discriminant, meaning whatever's under this root here, right? We equate it to 0, and we are going to have 3 minus 12k squared equals 0. Let me simplify this. By simplifying, I'm going to have 1 minus 4k squared equals 0. And let me move my 1 to the other side. I'm going to have minus 4k squared equals minus 1. Let's get rid of the negative by dividing by negative, meaning we are going to have k squared equals 1. 4k squared equals 1. Let's divide by 4 on either side, and we are left with k squared equals a quarter. And let's get rid of our squared here. We get rid of our squared by using a square root. Meaning we are left with k equals plus or minus a half. Now, after finding your value for k, you need to go back to your original equation and see whether you will have roots that are equal and real, right? How do you do that? By substituting your value for k in our equation, right? let's do that. But then I'm only going to use this part here. Meaning what I need to get under that root should give us 0. What I need to get under that root should give us 0. Let's start. Meaning we are going to have, let me write the square root for clarity's sake. It's going to be 3 minus 12 times a half all squared. Right, meaning we are going to be left with 3 minus 12 times 1 over 4. Now multiplying the 12 by a quarter should be 3. 12 divided by 4 should be 3. Meaning here we are left with 3 minus 3, which is 0. And we have proved our answer. We have a 0 under our square root. Now, by being equal, the square root of 0 is 0, right? Whether you plus or minus, you will still have this negative 5 here, meaning they are equal. Whether you plus or minus, you still have a negative 5 over 4. Whether you plus or minus the 0, you will be left with 5 over 4, meaning our roots are equal. So this statement is true and our answer is correct. Our answer is k equals a negative a half, k equals a positive and a half. Let's move on to our last part of this grade 11 question paper. Now it says show without the use of a calculator let me just rewrite this. Without the use of a calculator, that the 12th root of 10, the 12th root of 10 times the 6th root of 640 times the 4th root of 810 times the root of 40 equals 120. Meaning from this we are only going to deal with this part of our expression, right? We are only going to deal with that part of our expression because we need to prove it to be equals to 120, right? Let's move on. Now the first step, I'm gonna write this portion as 10 to the power of 1 over 12, right? And I'm gonna write this part I'm not sure if my color of the pen is clear. I'm gonna write this part as the 6th root, and let's try to write this in simpler terms. Let's try to write this in simpler terms and say 64 times 10. Let's write it as 64 times 10, and we are going to try and write everything else in a much simpler form. Let's move on to this part here. How do we write that part in a much simpler form? It says it is the 4th root, right? The 4th root of 810. The 4th root of 810. And we can write this in a simpler form by saying 81 times 10, right? Let's move on to this part, right? And write it in a much simpler form. Let's try to write it in a much simpler form. In a simpler form, we can say the root of 2 squared times 10, right? And then here, like I said, I wrote it as 10 to the power of 12, 10 to the power of 12, and then here we have the root of 64, the 6th root of 64, and we can try to get the prime base of 64, which we can write it as 2 to the power of 6 times 10, and we're going to do the same with 81, and 81 we can do the same with 81. Let me try to get different markers here. 81 we can say the 4th root of 3 to the power of 4 times 10, which is still the same, and say 2 to the power of 2 times 10. Let me try to create some space for myself here. Let me try to create some space and try to rewrite everything. Like I said, here we have 10 to the power of 1 over 12 times the 6th root of 2 to the power of 6, 2 to the power of 6 times 10 times the 4th root of 3 to the power of 4 3 to the power of 4 times 10 times the square root of 2 to the power of 2 times 10. Now let's focus on this part only. Let's focus on this part only. On the part of this root here, right? and try to write it in a simpler form. And let's try to write it in a simpler form. And we are going to do the same with this part here, and we are going to do the same with this as well. Meaning we are going to have 10 to the power of 1 over 12, and then this part here, this 6th root, you know it's any base to the power of 1 over 6, right? Any base to the power of 1 over 6, to the power of 1 over 6, right? Any base to the power of 1 over 6, this 6th root here. So we can write it in terms of 2 to the power of 6 over 6, because 2 is raised to the 6th power. So we can write it as 6 over 6 times 10 to the power of 1 over 6. And we are going to do the same with this part here, right? Meaning we have 3 to the power of 4 over 4 times 10 to the power of 1 over 4. And then here we have 2 to the power of 2 over 2 times 10 to the power of 1 over 2. Right? Now let's try to simplify this. Let's try to simplify this. Let's try to simplify this. Can you see here is 2 to the power of 1. And then here we have 3 to the power of 1 as well. And then here we have 2 to the power of 1. Right? Now let's write it in those terms. In those terms. Meaning we still have 10 to the power of 1 over 2 times 2 times 10 to the power of 1 over 6 times 3 times 10 to the power of 1 over 4 times 2 times 10 to the power of 1 over 2. Right? Now let's try from this point. Let's group our numbers. Those that are raised to a certain power on one side, those that are only a constant, let's put them on one side, right? Meaning we are going to have 2 times 3 times 2. Can you see? 2 times 3 times 2, right? Sorry, and let's group these ones as well. Let's group these ones as well. Let's group these ones as well that are raised to a certain power. Let's group them as well. Meaning we are going to have 10 to the power of half times 10 to the power of 1 over 6 times 10 to the power of a quarter, 10 to the power of a quarter times 10 to the power of a half. Now let's multiply our constants, meaning this part here, 2 times 3 is 6, we have 12, and let's solve this part here. Now for this, you need to go back to your exponential laws, right? Can you see we have the same bases? What do we need to do to our exponents? We need to add them, right? So I'm going to isolate only the exponents, but then write down the base, right? So our base is 10, right? And we have these exponents, right? And we need to add them, right? So let's add them. It's 1 over 2 plus 1 over 6. I'm going to run out of space. So let me just rewrite this here. 1 over 2 plus 1 over 6 plus 1 over 4 plus 1 over 2. Now we need to find our LCD in this case, right? So we can multiply everything by, let's say we need to get, so our LCD here, let's make it 12. So meaning here we're going to multiply by 2 over 2. This side, for our LCD to be 12, we are also going to multiply, this side, this part here, this section here, we are going to multiply by 6 over 6. This here, we are going to multiply by 2 over 2. This here, we are going to multiply by 3 over 3. This part here, we are going to multiply by 6 over 6, right? So we are going to have a 6 plus a 2 right? 6 plus 2, 3, 6. It's going to be, so it's going to be, let me rewrite it. It's going to be a 3 plus a 3 plus a 6 plus a 6, meaning from this point on we are left with let me take this off. And after finding your LCD, remember the base is 10, and then you find your LCD based on your exponents, right? Meaning your basis will be, your exponent would be 12 over 12. So it's 10 to the power of 12 over 12, which is 10 to the power of 1. And if you multiply the 12 to the 10, will give you 120. Should give you 120. Meaning we have proved and we have shown that the left hand side is equals to the right hand side. We have proved the left hand side is equals to the right hand side. This is a typical example. This is a typical example that tests whether you can apply your exponential laws properly, and you understand how to find the prime basis of whatever number that you're dealing with, right? This is a typical example of that, and I hope you guys, actually this is a nice sum for you guys to practice and understand the exponential laws and how to apply the prime basis and how to minus or add the exponents. All right, let's move on to our next segment. Now, if you look at your question paper, you should see that we are done with question 1 and question. You should see that we are done with question 1 and question 2 of grade 11 November paper 2017. We've managed to go through question 1 and question 2, and we are going to deal with question 3 and question 4 in the coming days. Now, grade 11's work actually provide a revision for grade 12. So what we are going to do now is get a question paper for grade 12 and also solve or go through question 1 and the question 2 as well, right? So in that case, we will be actually we would have gone through the first segment of the type of questions that you will get in terms of question 1 and question 2. All right, we are going to move to the matrix paper 1, and we are going to solve the one that is, we are going to go through the June 2016 paper 1 for the matrix. Now they say you must solve for x in 4x squared minus 25 equals 0, right? Let's start. Now from this you can straight away get your factors for x. You can straight away get your factors for x, 2x on the other side, and then we can say maybe minus 5 plus 5, meaning your x will equal 5 over 2, or your x will equal negative 5 over 2, right? Or there's a different way of solving this. You can say 4x squared minus 25 equals 0. You can take the 25 to the other side. On this side you are left with 4x squared equals 25, and then you can divide by 4 on both sides. Divide by 4 on both sides, meaning you are left with x squared equals 25 over 4. We are looking for x, meaning we need to get rid of this x. We need to get rid of the power of 2 by putting a root on both sides, meaning we will be left with x equals plus or minus the square root of 25 is 5. The square root of 4 is 2, meaning you are left with x equals plus or minus 5 over 2. Now that's easy 3 marks for you. Now let's move on to our next question, which says again solve for x. This is question 1.1.2. Says again solve for x. Let me just rewrite everything. It says solve for x, and then the statement says correct 2 decimal, to 2 decimal places. Now what needs to come to mind here is you need to find factors of x, but then your answer in this case now, it is irrational, right? Now what needs to come to mind? It means I can't factorize by getting the factors of x, right? They made it easy for you in this case, right? You can't try to factorize it, meaning you must use another method of solving for x. And in this case, we can use either the quadratic formula or completing the square. Let's solve it by using the quadratic formula, right? The quadratic formula, which is, oh, I forgot to write the whole sum down. Let me just write the whole sum down, which is x squared minus 5x minus 2 equals 0. Either way, there's no way you will get the factors. Factors of negative 2 are 2 and 1. And no matter how many times you add it, it will never add to a 5, right? Meaning, like I said, you can either use your formula or the quadratic formula, or you can complete the square. Let's solve this by using the quadratic formula, right? Meaning you will have x equals minus b square root of b squared minus 4ac minus 4ac all over 2a. Now let's get substituting here. Your a is your b. Let's start with the b. Your b is negative 5. So a negative and a negative, a negative and a negative will give you 5. Square root of, again, b is negative 5. So it's going to be negative 5 all squared minus 4. Your a is 1, and then your c is negative 2, right? All over 2 to the power 2 times 1. Now from this point on, what you do is just take your calculator. Let's try by adding everything under the square root. 5 squared minus 4 times negative 2 negative 2, and then it's 25 plus 33, which is 25 plus 8, which is 33. So it's 5. So it's 5 plus or minus 5 root of 33 all over 2 times 1, which is 2. And then from here, you can get your x should be 5.37, or your x, if you minus the 5 and the root of 3, will give you -5 minus 0.37. You can use this method, or you can use the completing the square type of method for this question, right? So, but I would prefer using the equation, so that you won't get into a bit of a trouble trying to complete the square, because there's a few steps that you need to follow when you complete the square, right? Now let's move on to question 1.1.3. 1.1.3. Again, you need to solve for x, and then they gave us, so let me just write it down, it's 1.1.3, and then we have 2 minus x all into x plus 4, which is greater than 0. Now we are dealing with an inequality, right? Now the first thing that you need to figure out, or you need to sort out, is this negative x here, right? We need to have it positive, right? So we can get it positive by dividing throughout by a negative, right? Meaning we will be left with x minus 2 bracket x plus 4. Now if you divide over an inequality, if you divide by a negative sign over an inequality, what happens? The sign of the inequality changes, right? Meaning now we are going to have less or equal to 0, right? Next step, remember what you need to do is find your critical values, right? Now in this case, your x minus 2 should be greater or equals to 0, or your x plus 4 should be less or equals to 0. Now I think by now you guys should have caught up to my method of solving inequalities. You will have your number line, and then you will have your values. In this case we have a negative 4, and we have a 2, right? Now you need to find the product of your signs, right? Let's write down the x minus 2, and then we have your x plus 4, right? Now let's choose a number. Let's pick a number which is less than negative 4, right? Let's go with negative 5 and put it in the space of x. If we put negative 5 here, what do we get? Negative 5 and a negative 2. What sign are we going to get there? Negative 7. So you only write the sign which is negative, right? Again, you do the same on this part here. We chose negative 5. Negative 5 plus 4, what do we get? We get a negative. Right? Let's move on to any number which is greater than 4. We can say negative 3, right? Negative 3, which sign do we get? Let me change my marker. Negative 3, negative 2, we get a negative sign. Negative 3 plus 4, we get a positive sign, right? Let's move on to the 2. Any number which is greater than 2. Let's choose a 3 and substitute it again here. 3 minus 2, what do you get? You get a positive sign. And then again, 3 plus 4, which sign do we get? We get a positive sign. And then we can underline there and find the product of our signs. Now here we have negative, and a negative should give us a positive, and then a negative and a negative and a positive, we have a negative, a positive and a positive, we have a positive, right? Now you go back to your critical values, right? You go back to your sum and say, they say whatever you have there, your values should be less or equals to 0, right? Now finding our critical values, we look at our signs, right, and see where your x is less than 0 or equals to 0. It's less than 0 or it is equals to 0 where we have a negative sign. Because if you look at your number line, you have 0 and then you have minus numbers and then you have positive numbers. So numbers which are less than 0 would be able to satisfy our equation, right? Now in this case, you should say x is an element of, again, let's look at our sign. Where do you get less than 0 or equals to 0? You get less than 0 or equals to 0. Let me change my marker. You'll get less than 0 or equals to 0 in here. You get less than 0 or equals to 0 between negative 4 and positive 2. Between negative 4 and positive 2, right? Meaning x is an element of close bracket negative 4 and positive 2 close bracket, because that's your restrictions, right? So your final answer should include your number line, and the critical values, and your notation. This is your final answer. All right, we're going to move on to the next question. Again, we need to solve for x, and we are going to try and solve 1.1.4 of the June 2016 question paper. And they say solve for x, and then they give you x minus 3x to the power of a half equals 4, right? Now you can get this into a standard quadratic form, but then you are dealing with x to the power of a half, right? What we can do here is try to write this in a root form and take our 4 to the other side and see what that takes us. Okay, let's start. Like I said, that's going to be my first step, and I'm going to have x. If I take the 4 to the other side, I'm going to have negative 4, and then I take negative 3x to the power of a half to the other side. I will have 3x to the power of a half, and I would write this in terms of the root, meaning it would be 3 root x. Right? Now after doing this, I still have to get rid of this, right? I still have to get rid of the root. How do I get rid of the root? By squaring. So let's square. Whatever I do here, I will have to do on the left hand side as well. So squaring this, we will have x minus 4 squared, and then by squaring this, I get rid of this square root, and I'm left with, remember you have to also say 3 squared, meaning I'm left with 9x. On this side is x squared minus 8x plus 8 minus 8x plus 4 squared. 4 squared is 16, sorry. Let me just rewrite my 4. So it's x squared, and then it's 8x, and then 4 squared, which is 16, equals 9x. Now let's write this in your standard quadratic form, meaning we will have x squared, we take the 9 to the other side, which will give us minus 17x plus 16 equals 0. Let's get the factors. I will have x and then x, and then I can say minus 16, and then on this side I can say minus 1. Your x equals 16, or your x equals 1. Now, like I said, whenever you solve this sort of equations, quadratic equations, you need to check whether both your solutions or your roots are correct by substituting back to the original equation. Now, if you take the 16 and substitute it back, check whether it satisfies your equation, and then the 1 again, right? After checking, you will see that the 16 is correct, and then the 1 is not correct, meaning your answer is x equals 16, or x should not equal 1. So x should not equal 1. Alright, let's move on to question 1.3.1, of which you are given f of x equals square root of 2x plus 1, and then the question says write the domain of f. That's one part of the question, which is 1.3.1, and then it says, the follow-up says, solve for x if f of x equals 2x minus 1. Now let's start with the first part, right, which is an easy one mark, meaning you can say 2x plus 1 should be less or equals to 0, and then you take the 1 to the other side, you have 2x equals 1, x is greater or equals to 1, and then your x should be greater or equals to a half. So this question will actually give you just 1 mark, which is an easy 1 mark to get. Now, following up this question, the follow-up of this question, they say solve for x if f of x equals to x minus 1, meaning you will, this giving you f of x, meaning you can equate f of x to this equation here, right? Meaning you will have 2x squared, 2x minus 1 equals the root of 2x plus 1. Let's get rid of our square root by squaring both sides. By squaring both sides, on the left you will have 4x squared plus 4x plus 1. On the left you will be left with 2x plus 1, because this root, the square root will cancel, the square will cancel the square root out, and let's bring everything else to one side. You will have 4x squared. If we take the 2 to the other side, this is the 1 will cancel out, meaning you'll be left with minus, actually it's plus 6x plus 6x, and the 1 and the 1 moving to the other side, they will cancel out, meaning everything will be equal to 0. And from here, sorry, it's 6x actually, because it's 6x, 4x plus 2x, meaning from this section here, from this part of our equation, you can take out the common factor, which is x, take out the common factor, which is x, and in the bracket you are left with 4x plus 6, and your final answer should be x should be equals to 0, or x should equal to, if you divide the 4 to 3, the 4 by this 6, it will be 2 over 3. 2 over 3. So those are your solutions to your roots for x. That will be your final answer, and this would be actually 3 marks in your question paper. So it's nice and easy, 3 marks for you, and you can move on to the next questions with confidence. That brings us to this last segment of algebra, and we've managed to complete question 1 and question 2 of grade 11, and as well the part of grade 12's question paper that deals with quadratic equations, simultaneous equations, exponents, and hopefully we've managed to actually help you guys and you understand how the question papers are set up and the type of questions that you will get. But then it's very important for you guys to practice every day and try to get as many correct answers as possible during your practice. And I would like to say good luck to the matrics who are starting to write the exams. And stay safe and do your best. Thank you guys for joining us and looking forward to our next session. Thank you very much. Bye.